So here is another question on graphical analysis of one-dimensional motion. So it is given that two stones are thrown simultaneously from the edge of a cliff 200 meters high with initial speeds of 15 meter per second and 30 meter per second. We have to verify that this graph here, this graph here, it correctly represents the time variation of the relative position of second stone with respect to first, that is displacement of first stone minus displacement of second stone, the position, the height difference. Okay, so this graph is accurate or not, that we have to verify. And some extra information is given, that is we have to neglect air resistance. Then we have to assume that the stones, they do not rebound after hitting the ground, and we have to take acceleration due to gravity. G is equal to 10 meter per second square. Okay, so let us first consider stone 1, okay, the first stone. Now before going into that, okay, first we must understand something. The position of the stone, we can represent it using equation S is equal to ut plus half at square. But here it is given that the two stones are thrown at some height above the ground, okay, 200 meters. So here another extra term will be added, which is the initial height, okay, the initial position at time t equals to 0, this. Okay, now since the stones are thrown upwards, and when something is thrown upwards, gravity is acting downwards, okay, so it will oppose it, it will become negative. So here relative position of stone 1, it can be represented as the initial velocity 15t minus 1/2 minus, because g is negative, 10t square plus initial position 200 meters above the ground, that is 200, that is the first stone. Okay, then second stone, initial velocity thrown upwards 30, so it will be 30t ut 30t again minus 1/2 10t square plus 200. This is the second stone. Okay, now the difference between these two, S2 minus S1, if we calculate that, it will only be all these terms will be getting cancelled, and it will be 30t minus 15t, which is equal to 15t. This is the thing. So this is a very important equation which will come into play, so we will be highlighting it here. Now we have to treat the individual stones separately. First, stone 1, okay, stone number 1. So there is a mountain cliff which is 200 meters above the ground, 200 meters above the ground. From there a stone, first stone, is thrown upwards with initial velocity of 15 meters per second. So obviously it will go upwards against gravity, and finally it will come to rest. Okay, here G is acting downwards, so it will be negative. So we have to find the time it takes to reach the highest position until 0 velocity. So that will be V is equal to U plus AT, which will be equal to V is 0, U is 15 minus GT, which is 10T. G is negative because it is acting downwards, movement of the stone is upwards. That implies T is how much? 15 by 10, that is 1.5 seconds. So it takes 1.5 seconds to reach this spot. Now if you remember, we have discussed the motion of an object under the influence of gravity. So when this stone, it reaches the highest point, to arrive at the same position, I am taking this outside, okay, here, okay, G is acting downwards, so it is alright if we keep it here. I have made the point. So when it reaches the highest position, from here again to come back to that position, exactly the same position, it will take the same amount of time, that is T upwards, upward journey 1.5 seconds, T downward journey also 1.5 seconds. Time of ascent is equal to time of descent for freely falling objects under the influence of gravity. So the total time, if we name these points, the total time from A to, let's say, B, and from B to C, it is A, B, C, that is equal to 2 into 1.5 seconds, that is equal to 3 seconds. Total time for stone 1, total time for stone 1 is equal to 3 seconds for until this position, okay, this up until A, B, C. Then from here it has to cover further 200 meters to reach the ground, okay. So that we can use this relationship, S is equal to UT plus half AT square, that implies 200 is equal to, here another interesting thing, velocity at identical positions, it is equal. It was thrown upwards at point A with 15 meter per second. So at this point C, identical position, its velocity will be 15 meter per second downwards, which is the initial velocity for this portion of the journey from, let's say, C to D, that is ground. From C to D, for this portion of the journey, initial velocity will be 15 meter per second, which is the velocity at the identical position A with respect to C. It was thrown upwards with 15 meter per second, and it will come down exactly at the same point. The velocity of the stone downwards will be 15 meter per second. Magnitude will be the same, direction opposite. I have already discussed it a lot of times before, so you can watch those videos. Motion under the influence of gravity and questions related to that. So here it is, 15t minus 1/2 10t square. That implies 200 is equal to 15t minus 5t square. No, sorry. This is, here there will be no minus sign. By mistake I have put the minus sign. See, here gravity is acting downwards. The motion of the stone is also downwards. So gravity will be supporting the motion. Here it will be positive, not negative. Okay. It's just a brain fade, is a bit of absent-mindedness, and it will cost you the wrong solution. Okay, so it is positive. So that will be, we'll be converting it into a quadratic equation. 5t square plus 15t minus 200 is equal to 0. So if we take 5 common, it will be t square plus 3t minus 40 is equal to 0. That implies t is equal to minus b plus minus b square 9 minus 4ac minus 4 into 1 minus 40. So 160, 4 into 40 is 160 by 2a, 2 into 1 which is 2. So that is equal to minus 3 plus minus root over of 169 is 13. This by 2. So it is either 13 minus 3 by 2 or minus 3 minus 13 by 2. Negative is not possible. So it is 13 minus 3, that is 10 by 2, that is equal to 5 seconds. That is the correct value of time. So this time is from T C point to D point, TCD, that is equal to 5 seconds. From here to here, okay, from here to here, that is equal to 5 seconds. So the total time taken by stone 1 is equal to TABC plus TCD, which is equal to 3 seconds plus 5 seconds, which is equal to 8 seconds. T1T, that is equal to 8 seconds. This is equation number 2. Now we have to consider stone 2. Okay, stone 2. So again here let's take a different, just in case if we require, space will not be enough. Okay, I'm taking that. Okay, for stone 2, again a cliff which is 200 meters above the ground. Okay, and the stone is thrown upwards with a velocity of 30 meters per second, which is the initial velocity. It goes upwards, it comes to rest. Okay, then again from that point it will come downwards. The velocity at this point will be the same, 30 meters per second. So here let us name these points P, Q, again Q, and this point R. Okay, this point here. Now we have to find how much time it takes from P to Q. So that will be V is equal to U plus AT. Again here G is acting downwards, motion of the ball is upwards, so in this case it will be negative. Final velocity 0, initial velocity 30 minus 10t minus gt, that implies t is equal to 3 seconds, which is from P to Q, and again from TQ to R will also be 3 seconds. Time of ascent is equal to time of descent. So TPQR will be equal to 3 plus 3, 6 seconds. Okay, then at this point the initial velocity for the journey from, let's say, R point to S point. Okay, for this the initial velocity, that is equal to 30 meters per second. Gravity is acting downwards, it is supporting the motion. So here for this it will be S is equal to ut plus half AT square. S is equal to 200 meters, the height of the cliff. Ut is 30 t plus G is supporting the motion, so plus 1/2 into 10 t square. So it is 30t plus 5t square. That implies 5t square plus 30t minus 200 is equal to 0. So that implies, taking 5 common again, t square plus 6t minus 40 is equal to 0. That implies t is equal to minus b plus minus b square, which is 36, minus 4 into 40, so it will become plus 160 by 2a, 2 into 1, 2, that is equal to minus 6. Root over of 196 is 14, I think. Yes, 14 over 456, yes, 196, minus 6 plus minus 14 by 2. Time cannot be negative, so we have to consider plus 14. 14 minus 6, which is equal to 8, 8 by 2, that is equal to 4 seconds. 4 seconds, which is time for the journey from R to S. So the total time for stone 2, that is equal to T PQR plus TRS, which is equal to 6 seconds, 3 plus 3, 6 seconds here, okay, PQR plus RS, which is equal to 4 seconds, that is equal to 10 seconds. The total time for stone 2. Now let us look at the graph. Okay, what are the important points? First, please pay attention here. First is this portion. S2 minus S1 is 15t. So if you look at this initial OA portion, it is a straight line passing through the origin with a certain slope. Okay, with a certain slope. Here at S2 minus S1 15t, if we put t is equal to 8 seconds, okay, 8 seconds. Why? Because stone 1 has hit the ground earlier. Okay, stone 1, total time taken for the journey of the stone from the top of the cliff to ground is 8 seconds. So stone 1 has hit the ground earlier as compared to stone 2, which has taken 10 seconds. So up until 8 seconds, both stone 1 and stone 2, they are in the air. Okay, first conclusion is stone 1 hits the ground earlier as compared to stone 2, as 8 seconds is lesser than 10 seconds. So up until 8 seconds, both stone 1 and 2 are in the air, and which is clearly given in the graph. Up until 8 seconds, both are in the air, so there is a difference between them, which is given by this 15t proportionality relationship. And if we put t is equal to 8 seconds here, S2 minus S1 will be equal to 15 into 8, that is equal to 120. Here also it is given the same. At t equals to 8 seconds, it is 120. Okay, so first thing is verified. Then after 8 seconds, stone 1 hit the ground, which means S1 is 0. After 8 seconds, S1 is 0. So we are only left with S2. Okay, when stone 1 hits the ground, S1 is equal to 0. So S2 minus S1 is only equal to S2. S2 minus S1 is only equal to S2. Here S2 is given by this relationship, this one, 30t minus 1/2 10t square plus 200. Now here this minus can sometimes be plus. When it is opposing, it is against gravity, it is minus. When it is with gravity, supported by it, it is plus. So there will be this t square, 1/2 t square thing, 30t plus minus t square plus 200, that thing, which explains the parabolic portion, A, B, this parabolic portion. Okay, the parabolic portion. Then see, stone 2 hits the ground at 10 seconds, t is equal to 10 seconds. So when stone 2 hits the ground also, when stone 2 hits the ground also, when stone 2 hits the ground, S2 is also equal to 0. So now S2 minus S1, that is also equal to 0. So from t equals to 10 second onwards, the BC portion, it is 0. S2 minus S1, that is equal to 0. Okay, after 10 seconds. So from 0 to 8 seconds, S2 minus S1 is equal to 15t, that relationship, proportional. Then after t equals to 8 seconds, S1 is equal to 0. So S2 minus S1 is equal to only S2, because of the t square term, the parabolic portion from A to B, and then after B, from B to C, after t equals 10 seconds, both have hit the ground. The difference between their position is 0, which explains the BC portion, it is 0. Okay, so this graph correctly, accurately depicts the relative position of second stone with respect to first for this condition, for this question. Okay, so a very good question on graphical analysis as well as motion of an object under the influence of gravity. Okay. So friends, I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to engineering, science and technology. Have a great day. Thank you very much.